Hello, physical science students. Welcome back. Today we're talking about how science works, and we're going to do this lesson in two parts. So today we're focusing on the scientific method, and then in the next lesson we're going to talk about another way that scientists answer questions, and that's through something called the CER method. So today's focus is the scientific method, and the scientific method is just simply a process or steps that are taken to produce reliable results anytime we want to answer a specific question. And many of the labs that we do this year are going to require us to go through the steps of the scientific method in order to answer questions that might come up during the course. So it's important for us to take the time initially at the beginning of the physical science course to talk about the scientific method so that when we do those labs, you're prepared and you know the steps. So there are 7 steps to the scientific method. Hopefully you have your notes in front of you. Make sure that you have the steps and then you jot down a little bit about what each step entails. So here's the definition. I think there's a place in your notes for you to write the definition. Make sure that you have down the scientific method's a series of logical steps that scientists follow when they want to solve problems. And we all are considered scientists because we all have had a problem before and ask ourselves a question and then sought to find the answer to that question. Some of it's through research, and some of it is through experimentation. So let's look at step 1. This is the problem. And this is always going to be stated in question form because in this step, we're asking ourselves a question. What is it that we want to know? So a good example of a question that we could perform an experiment to find the answer to is here. So does a flower grow taller in plain water or fertilized water? So this is a complete sentence. It's in question form. It is something that is testable. It's not an opinion-based question. So an example of an opinion-based question might be, which flower grows best? Roses or dandelions, which is a weed, but we'll go with it. Best is hard to measure. It has to be something that's testable and measurable. So this is a good question because we can set up an experiment. Now, after you ask the question, you want to try to gather all the information that you can and conduct research because it is very likely that somebody has already taken the time to figure out the answer to your question. So a lot of times the scientific method simply stops here because somebody has already done the work to figure out the answer. So you're going to do research, you're going to gather information, you're going to figure out what is already known about your topic. So you can use people as sources, you can use the internet, textbooks, you can use books, there's journals, there's tons of ways that you can conduct research. So if we're going back to our question, do flowers grow taller when we fertilize them or when we just put plain water on them? If I'm trying to seek the answer to that question, I might go to the internet. That's the easiest place to go. Now, once you have a good background knowledge over your topic, you're going to form a hypothesis. So you're going to make an educated guess. Your educated guess needs to be a statement, it needs to be a complete sentence, and it needs to answer your original question from step 1 of the scientific method. It needs to answer your original question, and it needs to be based on the research that you've done. Okay, so an example would be a flower will grow taller if fertilizer is added to the water. So I did some research. It's looking pretty good that fertilizer is going to help my plant grow taller. So I formed a hypothesis. It is a statement, it is a complete sentence, and it answers my original question. Also, you need to know that sometimes you might be required to form your hypothesis as an if-then statement. So if that is the case, you might say, if a flower is fertilized, then it will grow taller. So if your teacher requires that you do an if-then statement, that might be something that you want to do. All right, next is the experiment phase. So this is where you set up an experiment, and every experiment has to have two groups. You have to have an experimental group, and then you have to have a control group. So the experimental group actually gets the variable, and a variable is a change in the experiment, and it's what you as the experimenter changes. And then the control group is going to be the unaltered version. It's going to get the normal treatment. And this group is important because it's going to be what we use to measure growth or change by. So if I'm setting up this experiment, I might have a flower, and I'm going to provide that flower with some water mixed with fertilizer. So the experimental group is getting my test, which is the fertilizer. That is my variable. The control group is going to get the normal treatment. So we normally water flowers with just plain water. So the flower that gets the plain water will count as my control group. So here's an example of what this might look like in chart form. I have included the results here. So this would be like what's included in the data section. So I have my flowers. I'm labeling them plant A and plant B. Something that I want to point out is very important that you only make one change in an experiment. So we call that the independent variable. It's what you change, you the experimenter change in the experiment. So our plant needs to be exactly the same type of plant. I can't use two different flowers. I have to use the same plant. So A and B would be the same type of plant. The amount of water that I give both plants has to be the same. The amount of sunlight they get, where they're placed in the room has to be the same. Everything, the type of soil that they're put in has to be the same. The only change that we can make is we're going to add a little bit of fertilizer to plant A because this is my experimental group. So we call all of these things that remain the same within the experiment the control. And then, of course, the thing that changes we call the variable. I'm sorry, I said that wrong. Not the control, the constant. So things in an experiment that remain the same are the constants. And then the thing that is changed, the one thing that the experimenter changes, is known as the variable. Now, you might be looking at this chart and you might notice that there's a second change. So you as the experimenter, when you're conducting the experiment, it's important that you only make one change, but there's going to be a change that happens on its own. By itself. We call this the dependent variable. So the dependent variable is the thing that you measure. So we would measure height in the case of our plant. And so you'll notice that the height is different. So that's another variable, but we call this the dependent variable because this is out of our control. So in step 5, you'll actually record the data, which is kind of what we saw in the previous slide, and then you analyze that data. So if this were my data, I would kind of look at it and then I would draw a conclusion based on that. And of course, my conclusion here would be that plants that are when fertilizer is added to the plant, it does indeed grow taller. So when you have data, this can be in the form of a chart, a table, a graph, a lab report. It can be, we'll see the data in different ways. Mostly in physical science, we're going to use data tables. So in step 6, you will state your conclusion. The conclusion needs to be a complete sentence. It needs to answer the original question. So don't stray away, stick with the original question, and it has to be supported by data. When I grade scientific method labs, this is where I take off points most of the time because I'll read conclusions and I'll go back to the data table to make sure that the data supports the conclusion, and a lot of times it doesn't. Don't create a conclusion based on what you think should have happened. Form a conclusion based on what your data says happened. So I'm going to go back. If this is my data table, my data says that when we add fertilizer to water, then our plant grows 2 centimeters taller. So that would be what I would say in my conclusion. You might also be asked to add a second sentence to your conclusion that just states whether your hypothesis was proven or disproven. Now, it is very important that in the last step, you repeat the work. So if we were scientists that really wanted to seek the answer to our question, we would want to do this experiment over and over and over again, just to make sure that we get the same results every time and it wasn't just a fluke the first time. Now, in the science classroom, we often skip this step because we have to move on. We've got a lot of content to cover. So we don't oftentimes do step 7, but if we were in a science lab, we were going to publish these results, we would want to do the same experiment multiple times. All right, so that is the end of our scientific method lesson. The next lesson, we're going to talk about another way that scientists answer questions, which is called the CER method.